talk is entitled "A Framework is No Architecture," and well, just give me a chance and listen into what I gotta say. It's probably going to be interesting, and we're going to have a lot of fun. You're going to witness a world premiere right here. So I've been basically working frenetically for the last 10 minutes to put this keynote together. This is what I do. I work for a company called the PHP Consulting Company. We are sharing experience, which basically means that we help developers become better developers, which we think is the only way to make the world make the PHP world a little better. So basically what we do is, if you hire us, we get into your company and tell your boss that he's supposed to give you a raise. And if you are the boss, then we get into the company and telling you that you should fire the developers. Now, that was a joke. You can look that up on the internet if you're interested in what we really do. We basically work, I think we're active on 5 continents as of today. And we're working for, starting with a small web agency and small web startups you've never heard of, to companies that you maybe have heard of, like Facebook and stuff. So, without further ado, I would like to spend the majority of this talk about one of my favorite topics, and that is MVC, which we all know is short for Model View Controller. So what the hell is that? Martin Fowler, whom I like to quote, put it that way, very aptly in my opinion. He said, Model View Controller is one of the most quoted and most misquoted patterns around. I have no clue why my computer tells me the slide number right in the middle of the slide, so I can't actually read the text. It's really brilliant. Okay, never mind. So usually when I get into companies or when I do talks, I ask the question, who can tell what MVC is? I'm not going to do that today, because there's various reasons for that. We'll get to that. I've been looking around the web. As we all know, there's a plethora of PHP frameworks, and I wanted to make sure that I sort of get the best bits and pieces, what they think, what their take of MVC is. And the Yi framework, for example, says the central idea behind MVC is code reusability and separation of concerns. That's awesome. I really like that. I'm not really sure why we need MVC to achieve something that OOP already promises, but anyway, I think it's a good start. MVC is a software approach that separates application logic from presentation. That's what CodeIgniter says. That's a nice one. I like this. Separate presentation, actually one of the main advantages of MVC. We'll get to that in a couple of minutes. And CodeIgniter has a fairly loose approach to MVC, since models are not required. So that makes CodeIgniter a VC framework, which does not mean you're going to gain a lot of venture capital. You can talk to Zend about their Zend framework, which also is a VC framework, because in their documentation they're going to tell you, we're not going to tell you what the model is. You have to come up with the model on your own. Well, discuss the MVC pattern as it pertains to Kohana. Perhaps have an image, etc. That's the documentation updated 2010. That's what Kohana framework has to say about MVC. So it's an MVC framework, but they sort of still don't seem to be clear about the MVC thing themselves. At least the world has been waiting for documentation on that for just 3 years. That makes it a really, really perfect open source project, I think. Okay, this is what, of course, that had to be in. Type 3 Flow promotes the use of the Model View Controller pattern, which clearly separates the information, representation, and mediation into separated building blocks. The first time I read that sentence, I said, what the fuck? And then I started thinking and said, okay, that's brilliant. That's really nice. Because they really sort of describe what it's about, I think. Well, what is it about anyway? we still have to figure that out, right? So let's take a look in the past. We'll take a time warp back to 1990. 1990, three very, very notable things happened in this world. Okay, number one, sorry?
Shall I borrow it to my Mac?
Yeah, I know that everybody dealing with beautiful software will always make that joke. Thank you. So, three notable things happened in this world. Number one, Mr. Nelson Mandela gets released from prison, which I think was an awesome step towards freedom in this world. The second step, an awesome step the world took, 1990, you may remember, the Cold War ends and Germany reunites. That was pretty awesome. And then in 1990, I graduated from college. That was a joke. Microsoft releases Windows 3.0. And this is the world's first web server. It's the next workstation of Sir Tim Berners-Lee, who wasn't Sir back then. If you want to be a Sir, you have to invent the World Wide Web, or something like it. And this is really awesome, because I don't know if you can read it, it says, "This machine is a server, do not power down." So he asked the cleaning personnel to not power down the web in its early form. And I think what he did was something that quite often happens. He was working at CERN on something completely different, and sort of came up with the web. And it turned out to be a brilliant idea. And as we all know, in the beginning of the 1990s, then the web spread pretty quickly. And there's a lot of people nowadays who still think that the web is the internet. It's not quite the same, but we don't really worry about those details. So the funny thing is that Steve Jobs made it possible to invent the internet. I don't know if you've realized that, because that's the Next workstation. And Next was the company that Steve Jobs was running. Steve Jobs was running while he was not at Apple. They kicked him out at some point, and then he got back in. And in the meantime, he had that company Next, who created the workstation that Tim Berners-Lee ran the first web server on. So we'll probably have to thank Steve Jobs for the World Wide Web as well. Was that? Yeah. Did that make up for the epithet? So let's walk back even a little more. 1979. Who was born before 1979? Okay, that's a fair share. 1979, we get snow in the Sahara. NORAD Computer reports a massive Soviet nuclear strike on the United States. I think that's what inspired the movie War Games. And at some point it really happened in 1979. And then, I'm sure the thing that you will all agree is the most important thing that ever happened, Star Trek the motion picture premieres. And then something else happens in Norway. This man called Trygve Renskaug invented MVC. He was working on Smalltalk user interfaces. Back then, creating a user interface was sort of rocket science thing. It was really new at the time. Basically, there were a bunch of people working on graphical user interfaces. They then showed that to Steve Jobs, who adapted that so Apple could come up with beautiful user interfaces. Microsoft, I think, then copied Apple to create crappy user interfaces, and that's somehow how everything went downhill from then. But Trygve was working on MVC, and he's quoted saying, "I created the model view controller pattern as an obvious solution to the general problem of giving users control over their information as seen from multiple perspectives. I was actually I was thinking a couple of minutes as I was preparing this keynote, how that relates to Facebook. And I really don't have an answer to that. But anyway, it seems that dealing with information from multiple perspectives is what MVC is about. And then there's another quote of Trygve which I really like. MVC has created a surprising amount of interest. So what is this MVC thing? Usually, this is where I have the technical part of the presentation. Going over all that stuff, putting up a GUI application on the screen, and explaining you guys what MVC is all about. And I figured, since this is a keynote, we're going to have a fun time, and we're going to do that a little differently. So before we get started, I have something important to ask you. I'm going to ask you now to write something down. You can do that on your laptop or tablet. You can use a smartphone. If you're really old-fashioned, you can use a pen and paper. If you brought neither of those, that means you actually have to use your brain and memorize. Okay? But I'm sure you can do that. And I would like you to, as a favor for me, write down your personal definition of what is a model, what is a view, and what is a controller. And I'm promising you that you're not going to have to share that with anybody. It's a private thing. So you just do that on your own, and as I give you a minute to do that, and I'm not seeing people moving, so you get started now, and I'm going to prepare the next section of the show. I'm not going to continue until I've seen a couple of you at least taking notes. That's a fun thing. So really pull out your editor and write down what's a model, what's a view, what's a controller. It's just a one-sentence thing. Okay, guys, one sentence, but you might consider sending that over to some of the framework documentation groups then. Okay, well, thanks a lot. Now I got next question for you. Who knows the movie Pirates of the Caribbean? Awesome. You do? Okay, so I'm asking you to please participate on stage. We're going to act out model view controller, and you're going to be Bootstrap Bill Turner. That's a very, very important role. Who knows the movie Tron? Okay. So, users are not a myth. And I would like to ask the nice lady on stage, you're the user. Who can tell me which year the latest ISO SQL database standard that's currently valid was published? Okay, actually I don't have a clue either, it's 2011. Who can write a select statement? Okay, awesome. So I'm going to ask you to be the database. Then we need model, view, and controller. Any volunteers? So you can volunteer or I can volunteer you. Either way. Yeah, come on. Come on up. Come on up. You look awesome, you're the model. You look like a controller. Anybody visited the mountains recently? That was a nice view, right? Come on. So we are going to tell the guys that this is just a dry run. In fact, it's going to be the real thing, but I'm not going to tell them. So guys, this is just a dry run. Basically, you're taking that slowly, line by line. Don't worry if you screw up. I mean, it's just like software development, right? And just yell to them so that they can hear you. I think we ruined the microphone, didn't we? No. Does it work? So we can pass that around. And I'm sort of watching the whole thing. I'm going to see what happens. And first of all, Bootstrap Bill needs to do some work.
So persistence is always important, therefore we need a database.
Okay, so that's the position thing, so you need to position a database.
Database. I'm not going telling you whenever I like relations or not.
That was a joke, guys. Right? The relational versus NoSQL.
Now,
we gotta work on that.
Now we need a model. The model is initialized with the current gas price.
I forgot to tell you that I figured that we want to do something that really frequently changes. So I figured that we are going to display gas prices, right? So where's the model? Place the model. Right.
The view observes the model.
I'm watching you closely, model.
Both hands? Both hands?
The controller observes the view.
I'm watching the view.
Your line is, what a nice view, but never mind.
Well, what a nice view.
I'm getting tired. Can I lower my arm?
Only if you get swapped out to disk.
Shake your head. Shake your head. Shake your head. No. No swapping. Okay.
Can I use the system now?
Why does it always take so long for the application to bootstrap?
Shut up. Nobody has queried you. The view should display the current gas price, but it does not. We need to update the view. Model, tell them that you have changed your state.
I hereby publicly declare that I have changed my state. Dear model, would you please tell me the current gas price? But of course.
Bootstrapping is done. You can now use the system.
I'm now going to do a favor to the world and lower the gas prices. I can't find out how to lower the gas price.
Oops, did we forget to bootstrap some GUI elements?
You got it right there.
I can't read this.
So, clearly not a responsive design.
What the hell do you know about front-end design?
Quite often I'm coupled closer to it than you may think.
Can you guys please stop wasting bandwidth? Enter number of cents to increase the gas price.
Increase? I want to make the gas cheaper. Yeah. Yeah. Wait.
I hereby publicly declare that my state has changed.
That is awesome. So gas prices have increased again? Anyway, would you care to tell me how much I should increase the prices?
Yes, I'd love to.
Okay, I need to ask the right question. How many cents should the gas price be increased? Splendid. How lucky I am not to contain any validation code preventing me from using a negative value to increment the gas price. Model. Here is a gas price update.
And I'm the one that has to do all the work. I feel tempted to validate your input, dear controller, but if it is for greater good. So you guys should all be happy now.
No, we are not, because we can't see the update yet.
Of course. But yeah, I hereby publicly declare that my state has changed.
Dear model, would you please tell me the current gas price?
But of course.
Yay, I did it! I hacked the system!
So now where is that round of applause?
That's your round of applause. Thanks a lot for taking place. Go ahead. Software development is so much like real life and also team dynamics, I'd say. So, what did we just learn? The main thing that MVC is actually about is separate presentation, right? So the original idea was, I have that data and I want to be able to run a multiple document interface. That was very fancy at the time. You want to be able to open multiple windows to display the same piece of data, okay? So how are you going to make sure that all those windows stay in sync? This is where a model view controller comes into play. The first brilliant idea, back in the 70s, when an average computer had like 1 kilobyte of RAM, was let's save memory, and instead of storing the model redundantly in all those windows, we'll just create one central piece model thing. So we save resources, which is brilliant. And then it is also obviously easier to keep the views in sync, because there is one canonical source of data. So to make that work, something like subject observer comes into play. That's another design pattern that actually has been made very, very popular by MVC, because it's a fundamental part of MVC. You have seen the two subject observer relationships right there. So if we step back, a little technical part there. Those dotted lines are, well, I'm not really clear what the dotted or the real lines were, but we have a controller observing a view, and we have view observing the model. So the fun thing is, if the model changes, it's going to tell the world, my state has changed, and all the views attached to the model can then update themselves. And I'm saying all the views, because in our example, we just had one view because we have a small stage here. In a real life scenario, you have multiple views. You have different windows, that's different views. Maybe a view is also just a GUI element, displaying one aspect of the model, like the whatever part behind the cents, because I think they have the 5 or 6 digit gas prices, so they can round up to something and make it look cheaper than it does. And we have one controller attached to each view. So basically a controller is a device driver of the view. The controller listens to the events that the view receives and handles them. Okay? So, separate presentation, the main thing. And, well, it's awesome to observe that we need a pattern like MVC to achieve that, because if you think about the PHP application, separate presentation is what any templating engine gives you, right? You have a template system, whatever that may be, and that contains the presentation logic. That's separate from whatever the rest is. So separate presentation is something that's actually pretty common in the application world. If you think of the old dark ages, PHP 4 times, where we had like separations of concern at the character level, so we had SQL, HTML, and PHP and everything in one file. That's clearly not a separate presentation. But I think that the template engines have, well, first and foremost, the web agencies started to use them a lot, and that has brought separate presentation pretty much into the world. And it's really rare these days that I get into a code review and see people opening database connections from their views. Yeah, I get to see it every once in a while, but it's becoming really rare. And as a matter of fact, a lot of people think that PHP in itself is a templating language and a templating engine, if you want, so you don't really have to use a templating engine. You can use vanilla PHP to achieve the same effect. Using a templating engine usually puts more restrictions on what the developers can do and how they can screw up, and in a lot of scenarios that's a really good idea. So MVC is meant for these multiple document interfaces, and one of the main key factors that MVC achieves is keeping all those views in sync. Okay? Awesome. Now let's take that to the web. We can't blame Trygve, because he came up with MVC in 1979, and the web came up not before 1990. So looking 11 years ahead, you can't really blame somebody for not taking the web into account. And I think the web is a brilliant concept. We have a stateless client-server architecture communicating over a simple text-based protocol called HTTP. This is completely awesome, and we all know that a lot of great things have been built on top of the web. But we have a minor problem with regards to MVC. On the web, the view is remote. The view happens in the browser. That's the client. PHP happens in the server. So how are you going to set up a subject-observer relationship between the client and the server? You are not. You can still send HTTP requests from the client to the server, so that part sort of works. You can use AJAX to do that asynchronously, so basically we can cover that. But when it comes to the view, observing the model, that's a tough one. We really can't do that. I mean, there is very, very late technologies that sort of allow that, with a whole new set of problems they bring with them. But let's just imagine we have the view on the client and everything else is on the server, and client and server have to communicate for each and every state change of a GUI element, which usually is a JavaScript event, like on Blur. You entered something, and then field loses focus, which means some updates have to happen. So you may be tempted to send an AJAX request to the server, to have the server controller do its work, and then update the model, and then figure out a way to update the client again. Well, basically you can do it with an AJAX request. What you got then is an application with a remote GUI. Has anybody before the year 2000 ever tried to work with a remote X11 desktop over a internet connection where you could use 1 or 2 hands to count the number of bytes per second that go through. Did you guys enjoy it? Not quite. So that doesn't work. It does not work. It's not going to perform. It's not going to give a decent user experience. So basically that means that MVC does not work on the web. It just does not work. Okay, let's cover that a little more in depth. We have a few additional responsibilities on the web. Now in this play that was so brilliantly acted out, we realized that we bootstrapped the application, wire up everything, and then the application just worked. I mean, that's like a GUI application, right? You bootstrap it. Who does Java? You're bootstrapping that monolithic Java application. Takes you 10 minutes. You need to power up another of these atomic things to actually power the application, whatever, and it sits in memory for ages until the server burns down, but it's bootstrapped, and everything is wired up. Right. We really can't do that on the web with PHP. We have a by request architecture, so we'll have to bootstrap everything on every request again. Now the problem is, we have no clue where the model is, right? So we have the view who's on the client, who's sending an HTTP request to the controller. Does the client talk to the controller? Well, usually you put something like a front controller in there. You want to tunnel all the requests through one front controller, which makes a lot of sense, among other things, from a security perspective. So you're not really talking directly to the controller. But anyway, it's some kind of controller, it's front controller, still the same term. So we're sending a request to the controller, to some kind of controller, and controller figures out that gas prices need to be lowered. Now where is the model? Where the hell is the model? We have to find the model. It's not there. And we can't bootstrap it up front because, well, how? So we need to find and load the model. That's a new responsibility. So we need a new component in the game that's responsible for finding and loading the model. And then, another tiny bit of change. Once the controller has told the model to do its work, the controller says, my state has changed. Now that's where we run into the big problem of not being able to talk to the view. What is the view in a web application? The view sort of degenerates to a string that we put together on the server. And that expands to a DOM tree, HTML, whatever page on the client. So basically the view is just the means of creating a dumb string, which is awesome, because if you think about it, then all we do the whole day is text processing. We receive a text request and we answer with another string. So whatever applications you guys have been writing, it's just, you get a string and you answer with another string. Basically, you can use a key value store to do that, if you are able to come up with all the strings that you want to be answering. Well, that's a very theoretical approach, though. So anyway, it seems like we have to select the view. It's not wired up. And things do not always go right. Things may go wrong. That means we may have to make a distinction, we may have to choose whether to display a success view or an error view. That again is a completely new responsibility. That's not part of the original MVC design. So the controller needs some means of selecting the view. Okay, and then we get a view, and we can ask the model for stuff and create a view from that. That again has nothing to do with the original model view controller thing, because we don't have to keep anything in sync. We don't have a multiple document interface running. We need to create one view. So suddenly there's just one view and not multiple views. Well, there is multiple views, but we have to choose from them. But then it's the one view that we're going to generate and send back to the client. And all that keeping stuff in sync, which is the intrinsic motivation of creating MVC in the first place, does not happen. Now the problem is that the view is a full page. It's not just telling, put the 197 there you are, and put that into the field displaying the gas price. But there's a whole HTML page of content that we have to fill. Where does the content come from? So we have to execute additional logic, whatever that may be. Usually it's different controllers, more controllers, to pull the data that make up the view that we're going to build. Because the thing that we were just processing is just a tiny little bit of content on the page. And the rest of the page's content has to come from somewhere. So we get controller chaining. We have to figure out a way of executing different controllers in sequence. And if you look at the existing MVC frameworks, there is a controller. There is usually no distinction between, well, what kind of controller is that? Is that sort of a master page controller that builds a page and uses some other controllers? There is a lot of derivative patterns like model view presenters and hierarchical MVC and all that kind of stuff that sort of tries to solve the problem. But still, the thing that they usually don't get is that the MVC in the first place absolutely makes no sense on the web. Because the problem it solves does not exist on the web. We have a lot of different problems that we have to solve, no question. One of my favorites is in the area of controller chaining is sending off forwards and redirects. Usually in the MVC examples that you see around, what people do is run a controller, and in figuring out what needs to happen, like I've successfully authenticated you, I'm going to redirect you to the profile page now. Guys, that's presentation logic. Sending a redirect is a very, very simple HTML page which just consists of that one header, but it's an HTML page that you're sending back to the client. So we're talking about presentation logic here. There's a distinction between the presentation logic part, which is creating that page, and the application logic part, which is figuring out that the workflow of the application should be the user needs to see that page next. This is usually something, if you follow the patterns that Fowler suggests in patterns of enterprise application architecture, this is something an application controller should do. The application controller is a component that you ask for, okay, you know what, I have just executed controller X, Y, or Z, and the result was success or fail, and based on the state of the application, which is sort of kept in the session in some way, can you please tell me what page the user is supposed to see next? This is where a general problem of web application programming shows up, namely we have a stateless protocol, and we need to a certain extent stateful applications. We need to be able to force the user to see a certain page. That's completely against the whole HTTP idea in itself, but still is something that we need to be doing. I mean, you have to log in now. Or if you want to do the checkout, you have to click through it in sequence, because you have to select your method of shipping first, and then we can calculate the cost for that. And we can't do it the other way around. It just doesn't work. So we can't let the user roam freely and access the pages in any order they like. So that's basically a thing that makes applications stateful. Your application wants to be able, or needs to be able, to force the users through a sort of assistant type. You need to see those windows in sequence, right? And this is something that you should explicitly have represented in code in your application, because it's a very, very central concept. And MVC doesn't give you this at all. All right, so if we try to sum it up, MVC on the web is a completely different pattern. The big problem with it, the big problem that I have with it is that the frameworks tell you there is MVC. Sometimes they even show you the same UML diagram that I would have copied from Wikipedia, but still it's a completely different architecture they are using. It's a completely different thing, because there's other responsibilities, there is more components that we need, and the whole MVC thing basically just covers a tiny little part of what makes the application architecture, if at best. We're going to expand on that a little in a minute. So, assigning more responsibilities is always a bad idea, we know that. We're talking about the single responsibility principle. Assigning different responsibilities is a different thing. So what remains is we have something that's called model, we have something that's called view, we have something that's called controller. And people are not really going to tell you what they are supposed to do and how they are going to work together to achieve what, because it's something completely different on the web. So I personally like to create whatever types of frameworks and name the things whatever you want to come up with, but not model, not view, and not controller, because those terms are sort of weird. Everybody seems to know what they are, but nobody really does. And I'm asking you, you've taken the note about what model, what view, and what controller is. At the end of the keynote, revisit what you have written down and rethink it and make up your mind whether that still fits. And then take it back and discuss it with your teams and with your fellow developers and say, guys, are we on the same term here? Because I keep asking teams that use MVC frameworks, just for the fun of it. I say, okay, can we come up with a short definition of MVC? And I'm telling you, they never agree. They never agree. Now imagine claiming that MVC is the heart and soul of your application's architecture. And at the same minute telling somebody that you don't really know what M, V, and C are supposed to do and how they exactly are supposed to interact. To me, that means that you haven't understood the architecture of your application, and this is a bad idea. So this is not a position you want to be in. Okay, so the interesting question is business logic versus, or domain logic if you want, versus application logic versus presentation logic. It's actually pretty tough to make that distinction, because on the web, quite a few times we basically only have presentation logic. It's just a bunch of data that we need to display. There is not too much domain logic happening in the web usually. But then there's quite a few companies that have a bunch of applications based on the same domain model. So they are sharing the same classes representing their business rules and everything. So this is where domain logic goes. Application logic goes somewhere else. So where you're going to put application logic? Quite a few times people will say, you know what, domain logic, that's the model, because that's a domain model. And I'm going to put application logic into the controller. I think that's a bad idea. It's awesome. Are controllers supposed to be reusable? A lot of people will say, yes, of course. I mean, that's the whole idea of MVC, make stuff reusable. Okay, so I'm telling you now what a controller does on the web. Ideally, you have your model, which is a business object, a domain object. It's cool. It does everything that you ever need your business to do and enforces all your business rules, and it's awesome. Now you put the controller on top of that, and the controller's job is to connect that business object to the web, to the HTTP thing, right? Because your model, your application logic, your domain logic, is not supposed to know anything about the fact that web exists. That's separation of concern, right? That's why we're all doing MVC in the first place, separated presentation. So we need the controller to do input mapping. Basically what the controller ends up doing is it takes an HTTP request and maps that to some parameterized call of a business logic method. It also has to find the model. We covered that. So in essence, the controller is an input mapper. Now making the controller an input mapper couples it to HTTP. Are you going to reuse the controller for a CLI request then? No, you're not. Because HTTP requests have named parameters and CLI requests have position parameters. And it's not trivial to sort of swap that out. So CLI request needs a different input mapping. So that either needs a different controller, or you have to figure out something that takes the input mapping and does that outside the controller so that you can reuse the controller. But in doing so, the controller would be empty because there's sort of nothing in it. What do you usually put in the controller? People say application logic. For example, I want to make sure that people are allowed to perform that business thing on the model there. That's awesome. So if you need to write a different controller, are you going to duplicate the logic then? I mean, if it's a CLI request, you need to duplicate what is in the controller. That's a bad idea. So obviously you can't put that in the controller. You want people to be able to access your stuff through an API, and the API suddenly does not know about your ACL, because that's in the web input controllers. It's also a bad idea. So what I actually suggest doing is put the application logic into proxies that look like domain objects and act like domain objects. They implement the same interface, and they do the access control and then delegate the method. It's a bit of an overhead technically, but it's a great separation of concerns, because then the controller doesn't really do anything. It's just input mapping. And then in the case of form validation, there's always the thing of, I need to figure out those error messages for all the fields, right? Because in the domain, usually the first invalid thing you get, you throw an exception, which is correct. But then on the web, you don't want to convert one exception to an error message to show it to the user. And so, okay, the first field is wrong, and once you have filled that out, I'm going to ask you to resubmit, and then I'm going to tell you that the second field is wrong. People are going to love you for that. So obviously it's on a way to go. What do? You need to validate all the input, and this is why validation logic usually gets duplicated in controllers. And a lot of the frameworks suggest, in a way, tying models to forms. That's something that I completely cannot understand. Why would you want to do that? Didn't we establish that a model doesn't know about the web? What's form processing in the first place? Let me tell you something. Form processing does not exist as a concept on the web. It does not exist. We get a post request, hopefully. Sometimes even a get request. But let's assume that we get a post request from a form. The server receives a post request. Everything is stateless. We basically have no clue that that was a form that has been posted. It's just data validation. It's creating error messages per field or per group of fields, and then finding a nice way of displaying that back to the user. But the form part is only a presentation thing. On the validation side, we do not care at all whether that comes from a form or not. And it violates separation of concerns to couple your models to a form. Now imagine that you have coupled your models to the database using some ORM mapping, which still gives you the flexibility to change stuff. But technically there is a coupling. And usually it's a sort of one-to-one coupling. You all remember Ruby on Rails and Active Record, and that was really a one-to-one coupling with all the negative consequences that has. So let's assume you're using something proper, uses a data mapper that really abstracts, but you still have the data coupling there. And then you also put forms to that, so you have right through your whole application architecture stack, you have a coupling. You're coupling your database to the forms. That's what we did in 1999, putting all the thing into one page. And it hasn't really improved since then. So please keep in mind that you really have to distinguish between domain logic, application logic, and presentation logic. Now, does the controller contain presentation logic? Ideally, yes. I mean, the original pattern pretty closely couples view and controller, because the controller is sort of the device driver of the view, right? On the web, there's a system boundary in between, so that coupling doesn't work. So the controller sort of drifts from being presentation logic to somewhere where I don't think it should be. Clearly, it shouldn't contain domain logic. At the end of the day, by the way, the funny thing is, if you do OOP and for a second you don't really care about the naming and say, you know what, I don't care whether that's a model or a controller, it's a class, I can instantiate, so I have an object, and that's a business object, and enforces business rules for me. Whether it does so by building a whole object structure in memory, or if it pulls stuff from the database directly or to the database, I don't really care. Then you have arrived at thinking in APIs, where you realize that the simple transaction script, where you just tell, okay, can you just update the profile page of user ID XYZ with this information, is essentially the same API, whether you run it through a simple transaction script, write it right to the database, or whether you build that complex domain model and run everything through that. From the API point of view, there is no difference. That's a fun thing. So that means you can start writing simple transaction scripts, then figure out what your application really is supposed to do, and then create a domain model for that, which is a very, very tough thing. I think especially the Typo and Flow community have put a lot of thought into that, and have, well, you guys have been talking a lot about domain-driven design, aspect-oriented programming, and all that cool kind of stuff. So at the end of the day, what is architecture in the first place? With all the basic terms, they have one thing in common: nobody can agree on a definition. My definition of architecture is we have a bunch of components with certain responsibilities, and they are interacting with each other. And architecture is about components and interaction of these components. That's a cool definition. Basically, that's an API thinking, okay? I have a component that has an API. It can do stuff. And this is how you should think about architecture. Whether you use a framework to implement a cool architecture, that's completely up to you. You can write crappy code without a framework, you can write crappy code with a framework. And you can write awesome code with a framework or without, and either way, it's the same thing. You need to understand the concepts. And you need to think about application. I firmly believe that architecture does not happen in incremental software design by chance, sort of. Let's start somewhere and architecture is magically going to happen. You have to have a software architect that's sort of one level up and thinks about architecture. Doesn't mean that you have to implement complex stuff that you don't need yet, but you have to think about it. And do not, at any rate, do not create monolithic systems. Do not put everything into one application. There is no point in doing so. If we draw up all the components that make up an architecture, there's a lot of components. And you know what? I don't really care whether I'm going to deploy all those components on the same system or on different systems when we get there. I don't care about that now. That's system architecture. We can do that later. As Bob Martin, Uncle Bob, Robert C. Martin, so aptly put it, good architecture allows you to defer design decisions. I don't care about where I'm going to deploy that next month. I can deploy it on one system. I can even run it in one process. I can deploy it on different systems. And if you use a proxy pattern, you can have a proxy as a client to a remote service implementing the same API that the server implements. So basically you have the choice of implementing the stuff and of deploying the stuff on one server or on any number of servers. That's what makes a flexible architecture. And that's, I think, what makes a really, really clear distinction between what we do in the PHP world, in the stateless scripted world, versus that Java type of application state world. And just because that's also cool, it doesn't mean that we have to copy that when we work in a by request architecture. Thanks for listening. Feel free to drop me a line if you have any questions. If you want one of those elephants, drop me a mail and give me a nice reason, and then I might be able to send you one. We have a you honestly don't own an elephant?
I own one, but I have 3 kids.
I have 2 kids, but I can relate to your problem. So I have to clear the stage for the next speaker. I'll be hanging out in the lounge for 1 or 2 hours at least. So if you want to talk to me, just find me over there and feel free to complain or say that you had a nice experience, whatever moves you. Thank you.